Okay, so for the last video in section 9.3, we're going to look at problem 11, which deals with the harmonic series. And this series is the sum of 1 over n, where n varies from 1 to infinity. And so it's equal to 1 plus a half plus a third plus a fourth, and so on. Okay, now as a side note, the name harmonic series does originally come from music. And so if you've studied some music theory, the name harmonic might be familiar to you. Okay, if you look at the overtones of a vibrating string, these are also known as the harmonics of the string. They have wavelengths of a half, a third, a fourth, and so on. And so this sum is in essence adding up all of those various wavelengths. All right, now part A, it says, note that the limit of a sub n as n approaches infinity, which is equal to the limit of 1 over n as n approaches infinity, is equal to 0. Can we conclude from this that the harmonic series converges? All right, now this is related to what we saw in question 9. So I first want to just remind you of the two results that we proved in that question. So we showed that if the series of a sub n converges, then it must be the case that a sub n approaches 0 as n approaches infinity. And we also proved, this is what we call the contrapositive of this conditional statement, that if a sub n does not go to 0 as n approaches infinity, then it must be the case that the series of a sub n diverges. Okay, now we have to be very careful, right? Because nowhere in these two statements does it say that if we know a sub n goes to 0, then we can conclude that the series either converges or diverges. And at the end of that video in question 9, right, I gave you that warning that said, look, if we only know this, right, that a sub n goes to 0, that's not enough to conclude on its own that the corresponding series converges or diverges. You got to do more work. Okay, so the answer to part A is a resounding no. Okay, so now with part B, it says, use the following inequality to show that the harmonic series actually diverges. All right, so here we have the harmonic series, and now I'm going to start grouping terms of this series as follows. Okay, I'll start out by grouping the third and the fourth, and what I'm going to do is trade in the 1/3 for 1/4, and since a third is larger than a fourth, that's why you see this inequality right here, right? The thing I'm going to write down on the right side is going to be less than or equal to what you see on the left. Okay, so that's the first grouping. Then I'm going to group the next 4 terms. So the 5th, the 6th, the 7th, and the 8th. And I'm going to trade in the 5th, the 6th, and the 7th for an 8th. And so here I get this group. And again, since the 5th, 6th, and 7th, they're all larger than an 8th, right? That only makes things smaller. Okay, then what am I going to do? I'm going to group the next 8 terms, so from a 9th to a 10th, 11th, 12th, so on and so forth, up to a 16th. I'm going to trade in all of those for a 16th. So here I'm going to have 8 of these 16ths added up, and again, it only makes things smaller. And I'm going to just continue in this pattern, right? So then I would group what? Well, the next 16 terms, and I'm going to trade all of those in for a 32nd, and so that's going to give me 16 32nds, so on and so forth. Okay, so the point here is that this sum I see on the right-hand side is really equal to 1 plus a half plus, well, a half there in green. Here this is 4/8, so a half there in purple. This is 8/16, so a half there in orange. And then as I noted, the 16 32nds, which is a half. Okay, by doing this grouping, I'm just going to get a half added to itself repeatedly. Okay, and so the partial sums of this series you see on the right hand side will diverge, right? They're going to blow up to infinity. And since the harmonic series, right, is bounded below by this thing that's blowing up, it itself must diverge. Okay, so our conclusion here is that the harmonic series diverges. All right, now in the next few sections, we're going to see the harmonic series come up in a number of different scenarios, and we're going to see a few other arguments as to why this thing diverges. All right, but that's a good place to stop here. I will see you next time. Thanks so much.